Imagine a small traveler, not much bigger than a car. This is Voyager 1. It left Earth in 1977 on a grand mission to journey to the giant planets, Jupiter and Saturn. Voyager 1 was our eyes and ears in the far reaches of our solar system, carrying the hopes and curiosity of all humankind. It flew past Jupiter, showing us swirling storms bigger than Earth and discovering new moons. Then it soared towards Saturn, revealing the rings made of countless pieces of ice and rock. Its initial mission was a stunning success, rewriting textbooks back on Earth. After visiting these giants, Voyager 1 kept going, faster and faster, away from the sun, towards the edge of our solar system. In 2012, it crossed into interstellar space, becoming a true pioneer. This brave little probe carries a golden record, a message in a bottle thrown into the cosmic sea. The record has sounds and images of Earth, music from different cultures, greetings in many languages, and pictures of people, animals, and places. It is a hello from humanity, a story of who we are, sent out to the stars, hoping that someday, somewhere, someone might find it and know we were here. Voyager 1 is now incredibly far away from us, billions of miles from Earth. Even light takes over 22 hours to travel that distance. To talk to us from so far out, Voyager 1 needs a very good antenna. It has a large dish antenna that must point very precisely towards Earth. If it turns away even a little bit, the connection is lost. This antenna is Voyager 1's lifeline. Without it, we would hear nothing but silence from the stars. Voyager 1 uses tiny rocket engines called thrusters to keep its antenna aimed perfectly. These thrusters give off small puffs of gas, making tiny adjustments to Voyager 1's direction. They are essential for the mission, ensuring our cosmic messenger can still phone home. For decades, these thrusters worked faithfully, but Voyager 1 is an old spacecraft. It has been working hard for nearly half a century, and parts can wear out. One day, the mission controllers at NASA noticed something troubling. The little puffs were not as effective as they used to be. The lifeline was becoming frayed. The attitude control thrusters began to show their age. They needed to fire for longer periods to get the same pointing effect, using more fuel than planned. This was a serious concern for the mission's longevity. If the thrusters became too weak, Voyager 1 would lose its ability to keep its antenna pointed at Earth. The connection would be severed, and we would no longer receive the precious data it was collecting from interstellar space. The scientists and engineers at NASA's Jet Propulsion Laboratory (JPL) were deeply worried. Losing contact with Voyager 1 was unthinkable. But how do you repair a spacecraft that is more than 13 billion miles away? The challenge was immense. Any command sent would take nearly a day to arrive and another day for confirmation. The spacecraft's technology was from the 1970s, with computers having less memory than your smartphone. It was a delicate, aging explorer, and any wrong move could silence it forever. The team faced a monumental task. The distance to Voyager 1 is hard to truly grasp. It is over 160 times the distance from the Earth to the Sun. Sending a signal takes over 22 hours, and another 22 hours for Voyager 1's response. This time, delay made everything incredibly complex. If they sent a command to fix the thrusters, they would not know if it worked for nearly 2 days. It was like performing surgery on a patient on another continent with only a very slow video link. Every decision had to be perfect. Voyager 1's technology is ancient by today's standards. Its main computers have only about 69 kilobytes of memory. Programming these old systems requires specialized knowledge. The original software was written in archaic computer languages. Many of the brilliant engineers who designed and built Voyager 1 were no longer at NASA. A new generation of engineers had to step up. They had to learn the spacecraft's old systems inside out. It was a race against time, trying to understand a machine from a different era to save it from a silent death. The engineers at NASA's Jet Propulsion Laboratory are some of the best problem solvers on the planet. They did not panic when Voyager 1's thrusters started to falter. Instead, they got to work, assembling a team of experts. Their first step was to understand the problem completely. They analyzed the data coming back from Voyager 1, looking at how the thrusters were performing. They ran simulations on computers here on Earth, trying to predict how much longer the current thrusters would last. The news was not good. The degradation was steady. Time was a luxury they did not have. The team dug through old Voyager documents looking for any clue, any idea, any system on board that might offer a solution. Was there another way to orient the spacecraft? Were there any backup systems they had forgotten about or never expected to use in this way? The pressure was immense. Voyager 1 was not just any spacecraft, it was a legend, the first human-made object to enter interstellar space. Losing it would be a terrible blow to science and to the human spirit of exploration. The team worked tirelessly, brainstorming, calculating, and debating. They knew they had to come up with something ingenious, and they had to do it soon. Then, a brilliant idea began to take shape. Voyager 1 had another set of thrusters called Trajectory Correction Maneuver Thrusters, or TCM thrusters. These were more robust thrusters, designed for larger adjustments to the spacecraft's flight path. They had not been fired since November 1980. That was over 37 years. Imagine trying to start a car engine that has been sitting untouched in a garage for nearly 4 decades. Nobody at NASA knew for sure if these thrusters would still work. They were the same age as the degrading ones, but they had been used much less. The idea was risky. What if firing these old TCM thrusters caused a new problem? What if they were stuck or fired too strongly, sending Voyager 1 into an uncontrolled tumble? But the primary thrusters were failing. Doing nothing meant certain mission failure eventually. Using the TCM thrusters, if they worked, could give Voyager 1 a new lease on life. It was a daring plan born out of necessity and a deep understanding of this incredible machine. Once the team decided to try the TCM thrusters, they began meticulous preparations. The TCM thrusters were designed for longer continuous burns, not the short pulses needed for attitude control, so the engineers had to write new software. They needed to command the thrusters to fire in tiny bursts, just a few milliseconds long. They tested their new software extensively, using a flight system on Earth that was a replica of Voyager's. They ran simulations again and again, checking every line of code. This careful testing took months of dedicated effort from the entire team. The day chosen for the test was November 28, 2017. The carefully crafted commands were sent as a radio signal, traveling at the speed of light. It took 19 hours and 35 minutes for that signal to reach the spacecraft. The entire team felt the weight of that moment. Then, the agonizing wait began. After the commands reached Voyager 1, the spacecraft would attempt to fire the TCM thrusters. It would then send a signal back to Earth with the results. That return signal would also take 19 hours and 35 minutes to arrive. So, everyone at JPL had to wait. For nearly 40 hours in total. They could only hope that their calculations were correct. Hope that the old thrusters would awaken. Hope that their beloved Voyager 1 would respond. The next day, November 29, 2017, was a day of incredible tension at JPL. The team gathered, watching their screens, waiting for the data that would tell them if their audacious plan had worked. Finally, the signal from Voyager 1, carrying news from across the interstellar gulf, arrived. The data streamed in, and hearts pounded in chests. And then, the news. Success. The TCM thrusters had fired perfectly. Each tiny millisecond-long pulse had delivered the exact amount of thrust expected. They had successfully reoriented the spacecraft. The backup thrusters, silent for 37 long years, had awakened and performed flawlessly. It was an astonishing achievement, a testament to the brilliant engineering of the original design and the ingenuity of the modern-day team who brought them back to life. A wave of relief and jubilation swept through the control room. There were cheers, high fives, and even tears of joy. They had done it. They had performed a remote repair of a system on a spacecraft billions of miles away. This successful fix meant that Voyager 1's mission could continue for several more years. By switching to the TCM thrusters for attitude control, they could significantly extend the spacecraft's operational life. It could continue to send back unprecedented data from interstellar space. Voyager 1 was reborn, ready to continue its lonely, magnificent journey into the cosmos. Today, in 2025, Voyager 1 continues its epic voyage, venturing ever deeper into the vast, uncharted territory of interstellar space. It is more than 15 billion miles from Earth, a tiny speck of human technology, carrying our curiosity into the cosmic ocean. It is a silent ambassador, a testament to our desire to explore, to understand our place in the universe. Voyager 1 is still sending back valuable information, teaching us about the interstellar medium, the stuff between stars. It measures cosmic rays, magnetic fields, and plasma that originate far beyond our solar system. Each piece of data is a precious gem, helping us paint a picture of our galaxy. The ingenious remote fix of its thrusters in 2017 is a shining example of human capability. It shows our remarkable ability to solve complex problems and our persistence in the face of enormous challenges. The ability to reach out across unimaginable distances and breathe new life into an aging explorer. It reminds us that with creativity, dedication, and collaboration, seemingly impossible things can be achieved. It is an inspiration for future generations of scientists, engineers, and dreamers. Voyager 1 and its twin Voyager 2 represent something profound about humanity. Our innate curiosity, our relentless drive to push boundaries, to see what lies beyond the next hill, or in this case, beyond the next star system. As Voyager 1 journeys onward carrying its golden record, it is a message of hope, a symbol of our quest for knowledge, a tiny echo of our existence, traveling through the vast silence perhaps for eons to come. Its legacy will endure, long after its signals fade. Voyager 1, our silent ambassador, continues its journey, a testament to human ingenuity and the spirit of exploration.